Next, I'd like to talk about a very important part of the Python language, which is the concept of functions. Now, functions are reusable chunks of Python code, and they usually have a name. We'll see in the next lecture that we can create functions without a name. Now, a function takes 0 or more arguments, these are the inputs, and they return a value. And by returning, this is saying that they're giving something back as an output. And if we don't explicitly return a value from a function, it will return none implicitly. So I have an example of what a function in Python looks like. I've called this function test underscore function. We know it's a function because it starts with this keyword here, def, D-E-F, for define. Then the arguments or the inputs come next in parentheses. And then we have an indented block of code. And remember, in Python, whitespace is significant. So this leading whitespace here says that this is code within the body of the function test underscore function. So then here on this next line, I am what's called calling the function. I'm giving some values for the arguments. And this is returning a value that I'm storing in the variable x. And so we then print test underscore function returns and x. So if we go ahead and run this, we'll see that we can see the values of the different arguments. We only passed 2 arguments in this instance, and that's because one of them has a default value. It has an equals sign and a default value defined in the definition of the function. We can see that it returned none because we don't have an explicit return statement. And then we can see that we can use the help function just like we can on any other Python object on our function. So really quickly, let's say that we wanted to actually return a value instead of just none. We could use the return keyword, and then any type we want to return, let's just use a string. So we'll say this is returned from the function, and we can see that that is now the value that is stored in x. So the general structure of a function is that we announce it with the def keyword. We then have the name of the function, which is test underscore function in this case. We have 0 or more arguments in parentheses, so it would be totally valid to have a function with no inputs. It would just be open parenthesis, close parenthesis. We can have different kinds of arguments to this function. Positional arguments are the arguments that don't have an equals sign. These are called keyword arguments. And so these are optional when you're calling the function because they have a default value. But because you can put the keyword arguments in any order, you need to have the positional arguments first in your function definition. Then we use a colon to denote the start of the function. We can add a documentation string, which is what's printed out when we run the help function. And then we have the body of the function followed by our return statement. Or again, if there's no return statement, the function will return none by default. Now we can't really talk about functions without going into some depth on something called scope. So bear with me with this example. This will take a few minutes to explain, but having this background will really help you understand how functions work in practice. So I have this little test example here where I'm defining some variables. So I have subject and action defined, and then I'm defining a function called tellStory. Now this function takes an argument. It has a single argument called subject. We have a documentation string that says tell a little story. So this is just a description of what this function does. I then have this variable which will validate this statement as we look at this example in more detail. I'm creating this variable called note within the body of this function that says this variable only exists within this function. And then I'm just printing subject and action in this function. So I'm going to call this 3 times in this example. The first time I'm going to say subject equals the slow tortoise. Then I'm just going to call the function with the input subject, and then I'm going to call it with subject equals subject, which is a little strange, but we'll look into this more. So I'll go ahead and run this. You can see that from this first line here, we call the tell story function, and we're explicitly setting the variable subject equal to the slow tortoise. So then when we come down to this print statement, we will print the slow tortoise, which will be replaced in this f string, and action. Now we never defined action within the body of this function, so it's actually taken from the outer scope. So not the scope of the function, but the scope outside of the function. So action kind of falls through into place here. And so we get the output, the slow tortoise, which again is what we set subject to, jumps over the lazy dog. But now we just said subject equals the slow tortoise, right? So why, when we call tell story with subject, do we still get the quick brown fox jumps over the lazy dog? Why not the slow tortoise again? And then what's going on here with this equals, where subject equals subject? So let's look at this actually down here with this color-coded example. But before we do that, I'll just verify this note that I made here, that the statement only exists within, that the variable only exists within the function tell story. So if I go ahead and run this, we can see that note is not defined, and that's because it has gone out of scope when the function ended. It's only defined within this function. So this might be super confusing at first, but I hope that this color-coded example will help you make a little sense of this. So we have two scopes in this example here. We have our outer scope, which I have as this blue color, and then we have an inner scope, which is the scope of the function. So when we defined our variables subject and action initially, they were defined in the outer scope. So I have them as blue variables here. We've also defined this function tell story in the outer scope, so it's also a blue label here. And then we have something interesting, which is that our inputs are defined in this inner scope. So this whole body of the function is in this yellow scope because it's indented relative to this function. And so when we define note within this function, it's defined in this yellow scope as well. And now we get into the interesting bit, which is that we can kind of mix these scopes together. So this subject in the inner scope takes precedence over the subject in the outer scope. So when I say subject in this function, it's using the value as defined within the function. But since action doesn't exist as a variable within this function, it's taken from the outer scope. It's not defined in the inner scope, so it's taken from the outer scope. Now this only works in one direction. I can access, in this case, the blue variables or blue names from within the yellow scope, but not the other way around. I can't use the yellow variables in the outer scope. So then when we call tell story, within the function definition, we're setting what these variables are in this argument list. So this is actually what the value of this variable will be in the inner scope of the function. So when I say subject equals the slow tortoise, I'm setting the value of subject within the function, within this yellow scope. Now if I just call tell story with subject, again, this yellow variable is not defined within the blue scope, so it's going to use subject as defined in the blue scope, which is the quick brown fox. And so that's why even though we set subject equals the slow tortoise, that's only within the context of this function, within the scope of the function. It's not outside of the function. And now even though this subject equals subject looks a little weird, hopefully you can see now that there are these two colors here, and we're setting the yellow variable subject, which is the value in the inner scope or the scope of the function, through the argument to the function, equal to subject the value in the blue scope. So this is kind of confusing, but you might see this fairly frequently because oftentimes people will write a function so they can have some reusable code, but they want to use the same variable names because those variable names just make sense. And so they'll have the same variable name, and they'll often do a construct like this, where you have the variable name equals the variable name. And the reason they do that is so they can set the value in a different scope. So that's kind of a long-winded explanation, but hopefully that adds a little bit of clarity here. The key point is that the scope of this function is different than the scope outside of the function. but the scope outside can sort of fall through into the scope, into the inner scope, the scope of the function. So we can still access these blue variables or blue names within this yellow scope. And as I mentioned, this is a one-way relationship. So we can go from an outer scope into an inner scope, but not the other way around, unless you use something like the global or non-local keywords. But those are a bit more advanced, and so I'm not going to be talking about those in this presentation series. Now, this concept applies both to functions and classes, and we'll talk about classes later. This does not apply to loops or if statements or flow control, which we'll also see later on in the course. So I have this other example here where I have a function where I'm defining x. X is my function. I have this inner scope where I have a variable message, which is going to be yellow because it's defined in this inner scope. I'm also defining a function within a function. This function y is also yellow because it's in this inner scope. And then that function has its own scope. So we're nesting another scope here, this red scope. But then I'm trying to call the function y. I'm trying to run the function y from the blue scope. And this isn't going to work. If I try and run this, it's going to say y is not defined. And that's because it's only valid in the yellow scope. Once I go back to blue, y is no longer defined. Neither is message for that matter. So if we wanted to run something like this, we could have our function x and our function y. We'd have to call the function y from a scope where it's defined. So itself, the yellow scope, or any inner scope, such as the red one. And then we can call the function x within a scope that's also valid. So if I run this, now it works. Because we've defined x and called x within scopes where x is a valid name. We've defined y and called y within scopes where y is a valid name. Now I briefly mentioned the return statement, so let's go a little bit more in depth with that. So a return statement is specifying the output of a function. It's how you return one or more values back from a function. So you could return a single value, like return x to return the variable x. In Python, you can also specify a more complex type to return. It doesn't have to be like in C where you define a function as returning, say, an integer. So you can return things like a tuple, or you could return a Boolean value like true or false. Now, functions are probably actually something you've seen before, maybe not in programming context, but probably in your math classes. So you've probably seen something like y equals f of x, and that's saying that y, some output, is a function of some input x. And so you might have that function be f of x equals x squared. And so then when you plug in some value x, the operation you're doing on that is squaring it, and then the return value would be, in this case, x squared. So x squared is the value the function outputs or returns in this case. Now, Python functions are a little bit different than functions you might have seen in your math classes because they can do special things that only computers can do. And that's things like read from or write to files or print results to the screen. So it wouldn't make sense to have a function in math that's like f of x equals print x and then x squared. Like that's not something you'd really expect to see. But in Python, that's totally valid. And so we could actually just have a function that, say, prints something to the screen. And these other things that are unrelated to the output of the function, like printing to the screen or reading from a file, are what we call side effects in programming. And besides that, though, functions in math and functions in Python are actually pretty similar. And so in Python, if we had this example of y equals f of x, where f of x is x squared, it might look something like def f of x. So we've named our function f, and we've given it an input or an argument x. We have a documentation string that says what this function does. And then our return value, our output from this function, is x squared. And so then we can say y equals f of x equals 5, or just y equals f of 5. And then if we print y, I think it'll be fairly intuitive that the answer will be 25, which is x squared. So you've really probably seen these before in some of your other classes. It doesn't transfer one-to-one to Python because of these things called side effects, but otherwise your background in math will really help with Python as well. So we have an exercise related to this about writing a hello world function. So in the following cell, create a function named hello world that takes no arguments. It should print hello world when you call the function. Then modify your function to take one optional argument that defaults to world. If called without an argument, your function should print hello world. If you pass a value to the function like Bob, your function should print hello Bob. Alright, so if you want to work on this exercise yourself, feel free to pause the video. I'm going to go ahead and start this though, so I'm going to use the def keyword to say I'm going to start a function. We're going to give this function the name hello world. We're going to say it has no arguments, and then we're going to use a colon and some indentation to denote the body of the function. So the first step here is just to print hello world. And now I've run this code, but nothing happened. What's wrong with this? Well, I never called this function. So I've defined the function, but I never actually called it. I never ran the code that's inside the body of the function. So if I just run hello world to call it, now we can see it prints hello, world. All right, perfect. But now if I were to pass an argument like Bob, you'll see our function is not set up to handle that. It takes 0 positional arguments, but 1 was given. So we could add, say, a name. And now if we wanted to print that name, we could use an f string and say hello, name. All right, perfect. So we've now said hello, Bob. But you'll notice this is not an optional argument, as the problem statement says. So if I delete this Bob text now, you'll see I get an error again. Now it's the kind of opposite error. Before I had one positional argument that I gave that wasn't needed. Now I gave no positional arguments, but I need one. And so if we want to have both behaviors with this one function, we could add an optional argument, name equals world. And so now if we call this with no inputs, we get hello, and then name is replaced with the default value of world. But if I say name equals Bob, say, we get hello, Bob. So now we've handled this function, and this function can print both hello world and hello some other name that we specify.